The point of today's lecture is going to be about recommendation systems, which are by definition trying to show you the most popular items, right? Hence the song. But before we start talking about popularity, a couple items from the news this weekend. I'll point out also that this is the new News You Can Use logo. The previous one was done by Peter, and this one I did on ChatGPT last night. One thing you should take away from this is text handling on the new update got a lot better, right? So the text handling in your previous assignment number 2 was tough. It's gotten a lot better. I'll show you actually next time some of the results of that, but it's really improved and I like it. This is an article that came out middle of January about a young woman who spends her hours talking to her AI boyfriend. And, you know, this is completely predictable based on what we talked about last time, right? The social responses to fluent chatbots, in particular ones that have really great voices, like the Chat GPT's female voice. It sounds like Scarlett Johansson. So this is completely predictable. Of course, there are companies whose business model is based on you falling in love with their bots. So the interesting other thing that happened, this is from a couple years ago, but a man who married a hologram in Japan can no longer communicate with his virtual wife. Can you guess why? Not because it was banned, but because they pushed a software update, right? So be aware that this kind of stuff happens, right? Software updates will be with us forever. Your AI boyfriend or girlfriend may not, right? So this is a whole interesting trend, and we'll chat about this more later. But I thought showing you these articles was interesting because it seems to be becoming more and more of a thing, much to my surprise. But there it is. So let's also talk about the results from the survey you took yesterday. There's a bunch of responses. Thank you for that. Let me summarize them in talking about 3 suggestions we got. First, a couple of people said, why did she use OLAT? Answer, because I don't have an account. I'm in some weird login permission state that I can't use it. You can, but I don't want to figure it out, truthfully. It's like I don't need another level of problems. Second big suggestion from a lot of people was start the class later. I would have, but this was the only slot they offered me. So I'm really sorry. But, you know, that's the way it goes. A couple of people said, well, it's hard to attend when I'm sick or have military service or whatever. And that's why I put up the videos, and that's why I put up the slides. So if you can't make it, you know, those are your options there. And just people have been emailing me about being out of class. Awesome, thank you. I can track everything that way, so I appreciate that. Some people had suggestions for additional topics. One person suggested including stuff about finance and fintech more generally, AI and finance, and we'll try to work that in the very last class. I'm not an expert in that area, so I will have to study up on it to find out. I have friends who are, though, and I'll talk to them about it. Second topic a couple of people mentioned was uses and failures of AI in big tech. And I thought that's what I was doing. Doesn't get much bigger tech than Google or Bing or Amazon, and so we've been, I think, doing that. If there's other particular things you want me to talk about, failure models and so on, let me know. One person said, well, why do we have 4 projects? Why don't we have just one project that lasts the entire term? And the reason is that, from my perspective, getting multiple data points is better than getting one data point. From your perspective, if you screw up that one project, you're hosed. You have no other option. This way, we make the risk for you smaller, and I get more data about you. So, and as I mentioned, a couple of people said, we have a lot of work in the beginning of the semester. Yes, I did it that way on purpose, so you would be freer in the middle. One person suggested AI for accessibility, and that's a great topic. I have a whole lecture on that, so I'll try to weave some of that stuff in. And the last topic, which I thought was really good, was HAI in the non-Western world. I wish I knew more about this. I would love to talk with anybody who does know about it. So if you know a lot about this, let me know. We'll work something out. I know a little bit about it, but it's complicated. So I will talk to my friends and see what they've got. So I'll try to work those in. So thank you for the survey feedback. Appreciate that. So today we're going to talk about recommendation systems. And you probably heard about this one, right? So this is the one I worked on the most. And we're going to talk about what works for people, how they work inside, and what people understand about them. And the results are kind of surprising. So when you type Google right like this, you get a set of auto-completions like this. A lot of people don't know that those auto-completions right there, those recommendations, are aggregated from the other previous million people who typed in recommendation engine. And these are the high frequency completions for that. Now, however, Google does a lot of work to massage that list. It's not just the pure list that you type there. So for example, one that gave us a lot of problem was, why is my boyfriend, right? And so the completions for that were, shall we say, not safe for work. So we have to do, so Google goes through a lot of process to make sure to remove violent imagery, sexist imagery, all that kind of, all those words that you wouldn't want to put up there. So I've seen people write papers looking at this as the frequency list. So they would claim the most common query completion was machine learning. And it's just not true, unfortunately. So don't write those papers. This is not a reliable data source. But it is incredibly useful for people because we find that by putting up the recommendations like this, the completion recommendation list, people click through to the thing they want to get to a lot faster. Because if you can save somebody 5 seconds of typing, which sounds trivial, it makes a huge difference for users. Because I will tell you, most users can't type, right? And so doing this kind of thing, and especially like we heard yesterday, in complicated orthographic languages like Chinese or Hindi, it's complicated to get all that stuff in. So completions like this really do help out. This is probably, this is used more times per day than any other recommendation service in the world. Roughly 2 billion times a day, kind of thing, that kind of. So recommendations like that are one thing. And of course, when you do the query, you get back a set of results. This is a set of recommendations, right? So Google, Bing, so on, are all recommendation engines. And what you're seeing here is people complain for a long time, Google only gives you 10 blue links. Well, that hasn't been true for about 12 years now, but nevertheless, you can see, for example, that up here, you get highlighted text, which is super relevant to your query. So in this case, it's a definition of it. There's also images over here, which not particularly helpful, but then you get a summary from Wikipedia. And those come and go depending on the topic, depending on the query. Also, one thing that's not a blue link is people also ask. So these are other variations on that query. They're recommendations of other ways to think about your query. Right? So there's a lot of recommendation stuff going on. And this is Bing's. And look at that list, that auto-completion list, and look at that auto-completion list. They're similar, but we don't, Bing and Google doesn't sort them quite the same way. And I'm surprised to see Quizlet on there. So it's a way to learn about recommendation engines. So. And this is, of course, their list. It's rather different because they provide a Copilot answer in the middle of their, it's actually after the first organic result. So if you put them side by side, you can see two very different ways of looking at these things. So here, Copilot is really up front and centered. Here, that's a Wikipedia extract, but there's no real AI entry here. I will tell you, having been in the room, this is a big battle. how much do you front and center your latest new technology? And so Google tends to be super conservative about these things. So unless the AI summary is like super relevant, super on topic, and is provable that you can do that, they won't include it. So you get very, very different UI treatments of recommendation systems. Okay, you know this, you love it. And a question that people ask a lot is, why don't you do something better? Why don't you have some fancy graphics thing? And why don't you just do a list like this? And the answer is, we tried. The whole field tried for decades to figure out a better way to present the results of a recommendation engine. And it turns out a simple list is actually the best UI element. It sounds dumb, and maybe somebody will figure out something better in the future, but I wasted a couple of years of my life trying to do a better UI for Google recommendations. And here's one. This is from 2022, I think. The list with a bunch of keywords here relevant to that hit, and a bunch of visualization stuff. And I will tell you, the students they tested this on love it. Awesome. Highest possible score. It'll be great. And when you test it on real people, they hate it. So the difference between your test population and reality can be big. So if you, for example, test any information visualization on just students, I ignore your paper. It's useless to me. It's not reflecting reality. If I test it on you, you're all great students. That's the problem. You're too smart. You know too much. And so students who are tested on this love it because they understand what a polar coordinate system is, right? And anybody outside the university has no idea what you're talking about. So, we live in a world of recommendation systems now, right? So there's one, you probably have used that one. There's another one, maybe you use that one. These are all instances of recommendations. So there's a recommendation system from Google. Here's one from YouTube about recommendation systems. Not to be too recursive, but YouTube is a recommendation system that's used a lot, right? And one of the things to realize is to start thinking about how do recommendations come to you in these forms? So here's Amazon, which you might have used. You do some query about, say, recommendation systems, and you get a list of books or whatever it is. And I was talking with Peter Norvig, the co-host of this class, the implicit co-host, and he said that his friend Greg Linden was the programmer in 1977, joined Amazon. And at the time, recommendations were all made on content and titles. So if you did a query for, say, cooking recipes from Switzerland, it would look for books with those words in the title. Okay? The big insight was that you could leverage the data of buying patterns and people's interest in something rather than the content. So here, Greg Linden figured out that he could do this collaborative filtering thing, and he recalls, Greg says he recalled when his program went live, Jeff Bezos walked in his office and literally bowed before me on his knees, chanting, "I am not worthy." Because the reason Bezos did that is that it vastly, vastly improved the click-through rate. Not a little bit, but by a lot, by like 12% or something, some ridiculous number. People in these games, in recommendation click-through games, would love to have a 0.5% increase. And he gave them a double-digit increase. So this guy, in his algorithm, was responsible for basically the growth of Amazon. So as you know, Bezos is a remarkable guy, he's an interesting person, but the real hero here is Greg Linden, who figured out that he could write this algorithm and build it. So this was the birth of collaborative filtering. Interesting thing, if you're a CS student and you've been working at HCIAI, collaborative filtering as a concept has been around since probably the early 90s, maybe late 80s. It's an old idea in this community. This was the first time it made it out. So this is really effective tech transfer, but the people who wrote about it didn't get credited. It's just the way the world works. Right? People invent stuff and it gets built into the culture, and then somebody translates it into workable code that ships in a product. So you see these kinds of recommendations in, for example, Bing News. There's a million different ways of doing this. Looks slightly different. It's tiles that are arranged in a grid rather than a linear list. Doesn't make much difference, except we know that people tend to go left, right, top, down. But visual attention is not evenly distributed. So articles over here get clicked through much less than articles over here. So you have to pay attention to how people perceive your user interface. So I will tell you, this position is worth about 1/3 of that position. It's that big. So you have to understand these kinds of things. So you've seen recommendations like this, and this is a Discover feed. So you haven't done, this is called a queryless recommendation. You go to the site, you connect to the service, and it says, here's the most interesting things this week. And it's aggregating generally over the whole space of songs or videos, whatever it is, and showing you the top rated ones. Kind of, right? Because there are other factors at work, including promotions. So somebody pays Spotify a lot of money and they will boost the ranking of their item. And what's interesting about that is the top page or two of these suggestions gets paid attention to. And if you're an artist and your result is on page 4 and you pay, say, $100,000 and get it boosted to page 3, you wasted your money. You're invisible. So these recommendation engines have huge amounts of power about the effect that they have on culture and community and consumption. Of course, Netflix is famous for their recommendation algorithm. And they switched from content filtering to collaborative filtering shortly after Amazon did that in the early 2000s. They also were famous for putting up the Netflix Prize. Have you heard about this? It was a data set that they put out about movies and watch patterns and so on and so on. And what they proposed to do is, we will give you a lot of money if you can write an algorithm that improves on the prediction of the click-through. And this went on for several years, and they actually got several really great improvements to their algorithm out of it. So it's one of those cases where, because they appealed to the whole community, they actually improved the performance. So I want to make an interesting distinction, right? We think about things like Google or Bing or whatever, or DuckDuckGo, as search engines that give recommendations. And searches look like this. Somebody asks the capital of France, MBA MVP 2023, Coupa Cafe menu, how to tie a tie. These are information-seeking queries. Just, there's one answer, just give it to me, right? So for example, the best answer for this is a YouTube video. The best answer for that is a single word, a single token, right? So the results you get vary by kind of query. By contrast, recommendations are more passive. You're looking to be informed about a space of things rather than a single information-seeking entity. So I might ask for recommendations for songs for workout, or pasta recipes, or funny videos, right? And so the use case is very different, and so the UI is very different, right? Rather than just giving you single results that you then have to open up and look at and extract your own information. The recommendation list is, here's a space of possible results. So it's worth thinking about that. So if you did use an LLM to ask for recommendations, here's one I did yesterday. What book do you recommend I read next? Now, Gemini doesn't know a lot about me. It's got a little bit of my search history. But what it does, and what I've done here is, I've clicked on the button that says Show Thinking. So I'll show you that in a second, but it comes back with this response of, that's a great question, right? Then it asks, so we start a conversation. This is very different than Spotify. I don't know about you, I haven't talked to Spotify recently, right? But Gemini, as a language model, doesn't know enough about you to make good recommendations. So it goes into this. And in particular, if you open up the thinking characterization there, you can see this is what is happening in the background at Gemini, or your favorite language model. So they've got this sort of template of things to do. So this is called chain of thought reasoning, where it's showing you the chain of things it's trying to do. And in the end, it says structure the response, start by acknowledging the request and asking for more information, right? So this is actually quite nice. However, if I just want, a funny romantic comedy to watch now, I don't want to have a long drawn-out conversation with my AI. So it's a trade-off, right? Because if I say to Gemini, now start tracking all my questions and all this stuff, it becomes a trade-off. How much do I want to give it about my personal data versus it being smart, doing the right thing? So in a sense, the way the recommendation systems work is that they have some space of items. It could be videos, it could be people, it could be books, it could be whatever. So you've got this space of all these items, okay? And what we're trying to do in building a recommendation system is we know we have a user, so it's an individual user or a demographic of users, right? So, but let's talk about just individual user. And what we're trying to do is create some function of that user that maps what we know about that user to recommended items. Right? So what that's going to look like, you can think about the data this way. This is the way a lot of this has been thought about for a long time. You build this table, basically, where you've got a user who ranked Star Wars as number 5. Perfect score. And you've got other items, different columns, right? And the problem is it's mostly empty space. If you're a Netflix, you've probably got, say, 1 million movies. The person is probably only rated 1 or 2, or in the case of extreme users, 10 to 20 or something like that. Okay? So given your table about this user is mostly empty space, what do you do? So one of the things you can do is compute the loss function, right? And so you use this model that predicts the question marks, predicts the missing ratings. What do you put into that model? That's the AI question, right? So what do you put into that, given that you know the user, you know the item, and you know a few ratings that they've given you? Is there some model we can do that will predict the missing ratings? So that's part one. Now let me tell you reality. Part two is that not only do you have the user and the model of the user, and the items and the model of the items, you also have the context in which they're asking that question. Asking for a movie to watch on a Friday night is not the same as show me a news program to watch on Monday morning. Different contexts. So a question for us as HCIAI people, what goes into the context? What goes into the context indeed? I've told you a couple different pieces of the way recommendation algorithms work. The old way was that they would do content-based filtering. Title, whatever the transcript you got of the movie or the book or whatever. And then there's collaborative filtering. But context is what? So let's just imagine now that we've got a bunch of different ways of characterizing context. So now you've just made the problem worse, Dan. You used to have a nice n by m table. Now you've got an m by n by x, so you've got how many of these do you care about? So the number of different contexts that you can recognize will give you a finer grained, better map to what the user wants. So the problem is this is a huge 3D space that's mostly empty. So we've got this problem of missing data, so we have to figure out what to do. So what goes into F? So the classic interpretation is it's going to be metadata about the items, things like the title, the genre, the artist, most of which you get from the provider. So when say Amazon gets a book from a publisher, they get the title, the genre, the artist, a review maybe, a bunch of metadata like that. You also get content data, which describes the thing itself. In the case of music, you get maybe the particular notes, the overall amplitude, loudness, the beat speed, et cetera, et cetera. You also can get collaborative filtering. Now, as I said, collaborative filtering is a sparse data problem. You don't have a lot of data. So maybe what we'll do is we'll pool users and try to identify similar groups. Okay? So you see we now have a second order problem going on. So do I pool all students at University of Zurich together as a similar group, or should I break them down more finely? Because what we're doing in the AI world is trying to identify a coherent chunk of people that have similar interests. So the answer is going to be find people with similar interests. And their age doesn't matter so much, their location doesn't matter so much, but their preferences expressed through ratings matter. So if I get a bunch of people who give Star Wars 5, make a Star Wars category. If you give them a bunch of, give it 1, you make that group over there. And you can label them as science fiction lovers and haters, but to first order, it doesn't matter, right? It's just groups. And also we can do things like using those kinds of ratings to embed semantics in the same way that word embeddings work, right? So think about extending it that way. So basically what we're trying to do is compute this loss model, this loss function, such that we can predict and have a decent prediction of a user that watches some particular element and gives a particular rating. Now, here's a big problem. So that's the model. In some sense, we can dig into that, details of that, but I want to focus on people. So here's the problem. That data is dominated by frequent raters. Because I will tell you, most people are over here. Most people on a Netflix or a Bumble or whatever give a relatively small number of ratings. 1, maybe 0. In fact, the majority of people on Amazon have given 0 ratings. The majority. So, and then you get a few casual users who do a few things. And the problem is you get the domination by frequent users. So frequent users have given thousands of ratings. Literally thousands of ratings. Sometimes these are influencers who are going on trying to extend their influence empire. But you get a few people who have vastly overrepresented. So what do we do? The observation here is that 20% of users have 80% of the impact on the ratings. So it's an 80-20 rule. So one thing you can do is to try to counterbalance that, and you basically weigh each user by the number of items that they've got, by the number of ratings that they give. So you counterbalance. So if they've given 1,000, you divide by 1,000, so right. You're basically trying to flatten out that curve. People who give them 0 ratings, I'm sorry, you're useless. Go away. So basically, this is the compensation mechanism for those very frequent users. You just divide by whatever their number is. And it works, right? After you do this kind of calculation, you will find that the improvement for non-frequent users approaches, in this case, the loss is 0, so it's quite good. Okay, so we've got recommendation systems. Are they good or bad? Are they helpful? Now, as a user, you might have opinions. If you use any dating app, like Bumble or Tinder or whatever, right? You might think it's really terrible, right? It depends on your experience. So what do people do? Well, a couple of years ago, Facebook got into a lot of trouble for running a study, and I'll tell you the study. So here the title, the headline is that Facebook manipulated almost 700,000 users' emotions for science. Well, let me tell you what happened here. I'll show you that in a second. What they did is they took 700,000 people and put them into an experimental group. And all they did was they modified the post recommendation algorithm slightly. What they did is that they moved a couple messages that contained positive words higher in the message order. So when you log in, you get your feed, right? Your feed of messages from friends and people you follow and all this stuff. What they did is they looked at that feed list for the person who's logged in, and looked at all the messages and said, oh, this one's more positive than this one. This one's negative. So this one has good positive words. Happy, helpful, wonderful, melodic, things like that. This post is negative. It's got nasty words in it, right? Or whatever. And what they did is they didn't delete anything. They moved sort of nasty ones down and positive ones up for the 700,000 people. And they moved them just by a little bit, by like 3 positions. And then they watched what these users did. Were these users more frequent posters? Were their posts more positive, more negative? Were they more interactive, less? They did a bunch of analysis of this. And what happened was that for that group of 700,000 people, they didn't delete any posts. They didn't hide anything. But what's interesting is that encouraging a kind of positive emotion by doing this tiny manipulation ended up actually impacting people. And the measure was, were their posts more positive or more negative? And they were slightly more positive. So it says here, and I love this, so the study result is that people who are in the positively going group produced an average of 1 fewer emotional word per day because they were less angry, less unhappy, per 1,000 words. It's a tiny effect. But the cool thing is, you've got 700,000 people looking at thousands of posts, so the sample size is quite large. It's in the millions, right? So you can have a very small effect size, but the significance can be quite high. Okay, I'm talking statistical significance. So we know this is a true effect, but it's a tiny effect. So this is an important kind of meta lesson for people in HCIAI. You can do stuff like this that has an effect, and you can measure it and show it's significant, but significant is not the same as important. Okay? It's not the same as important. So in this particular case, they got in a lot of trouble for doing this. One thing that we found out afterwards was that interviewing a bunch of the people who were in the study, their major objection, and the reason it got into the news, was that they objected to Facebook manipulating their feed. What are you doing, manipulating my feed? That's a violation of whatever, right? And what they thought was happening was that when they go to Facebook, their mental model says, I'm seeing all of the messages by all my friends in an unbroken thread. That's not true. It's never been true. It's never been true. Your feed is a highly curated set of messages from other people, and they get ranked with respect to you. Facebook is a recommendation engine that's recommending that you read these particular items in this sequence. And people, their naive mental models was, that's not true. I'm just seeing the feed, the unwashed, unvarnished feed of all my friends. That's not the case. The feed has always been manipulated. This is a tiny little manipulation, but people got really unhappy with being manipulated. So it's an interesting question, right? Everything is being manipulated and reordered and optimized for the person, the organization that's offering the feed. If you've got a recommendation engine, someone's optimizing that sequence of recommendations in order to make something that they care about better, right? So is that click-through rate? Is that watch time? Is that dates per day per person? So what do you do? So one of the things that's fascinating about this is that I'm going to contrast here ML engineers with HCIAI people, right? ML engineers want to make the best optimization possible, and I want to minimize my loss and maximize my gain. Awesome. However, the reality is that people change. So what you get is this feedback loop between recommending systems, recommending stuff, users using that and saying, oh, whatever, I hate this. And so they end up changing their their personal recommendation adoption behavior. And so you get this kind of co-evolving thing. So remember what I said, you can't leave a model alone? A model captures user preferences and recommendation systems in particular. It captures their behavior at a point in time, and their behavior will change over time. So you have to have this constant loop. So if you're an optimizing engineer, you have a permanent job, basically. So let me ask you, I've given you a bit of thought experiment here. So spend a couple of minutes and chat with your neighbors about this. Is it okay to run experiments like the one Facebook did on users with permission? Is it okay to optimize for more engagement? If you're not going to optimize for that, what are you going to optimize? Is it you want to minimize regret? So last time I asked people to do this in my last class, I said you had 5 minutes and they took 10. So I'm going to try to hold you to 5, okay? So let's go and talk about this with your neighbors and try to answer these questions, okay? Is it? All right, everybody. This is one of those. I'm glad you only took 5 minutes. So let me hear. What do people think about this? I saw a little group over here. You guys were chatting pretty happily. What do you think? You're getting called on.
With respect to social media, because I'm personally an opponent against social media.
Okay.
So I don't like the dopamine that we get from all these posts, all these feeds. So I wouldn't appreciate having to run an experiment. So if something like terms of agreement pops up that asks me if I want to be a part of an experiment, I would say no.
Okay, so you would say no personally. And
Yeah.
do you think it's okay policy for a company to do that?
We think it's okay if it is short. The description is short and clear. Not like in terms of
okay, but they
agreement.
should ask permission.
Yes.
Is your position? Okay, good. Okay, so this group says they should ask permission for every experiment you're in, right? Let me tell you, the harsh reality is that you're all constantly in experiments. Basically, every single website you go to is running experiments. Do you want to get a pop-up for everyone? Just asking, right? One of the things that's happened because of GDPR is you get all these pop-ups saying, you know, you're at this website, blah, blah, and you always hit accept and go on, right? I don't know about you, but it drives me crazy. It's added 1,000 clicks to my day. But anyway, I understand the position. Anybody else have another position? Yeah, what would you?
My point was, let's say instead of testing 700,000 people, they would say we change it for everyone. Then at the end, no one would complain, right?
If it's, right, then it becomes a system change,
Yes.
right?
So that's
right,
why
right.
I think like
okay.
experiments on certain people is okay too. So.
Okay, good, okay. Any other positions?
There are also, like, I think, good practices when there is the checkbox not for each experiment, but rather
Right.
conceptually. Are you okay to participate
Right.
in experiments? And
Right.
then one time you check and then it's set.
Okay, so one of the things you probably clicked a yes on was the terms of service. Just a question, how many people read the Facebook terms of service document? You're lying. Yeah, me too, right? I haven't read it either, and I'm heavily engaged in this area. And that's a real problem because, as you probably know, the terms of service for Facebook say that if you click this box, you agree to give your firstborn male child to them. Just kidding, but you know, it could be in there and you wouldn't know. Almost all the terms of service that I've seen have a provision for, yes, you agree to be in an experimental group.
But not explicit, because some services, I know that Google has in some
Yep.
services this explicit
Yeah.
checkbox that you want to be like in Vitas, and
Yeah.
and they find this a nice practice because then
Yes. That's right. So there's a very careful, obvious, explicit case. How about folks in the back? What did you guys think? Anything? Is it okay to optimize for engagement? Anybody have an opinion about that? Engagement? Where engagement in YouTube terms is watch time. Do you know, I don't know about you, but these algorithms have gotten really good. So Instagram, I end up spending far more time on Instagram than I thought. Does this happen to you, right? Yes.
Personally, I think it is problematic because there is a very high addiction chance, and I think
Yeah.
it's very much what the businesses want, because engagement for them is profit.
Right.
Which from a business perspective, of course, makes sense, but morally, I think is not
Exactly. Yep.
defendable.
Right. I hear you. Okay, so the question is, what's ethical about this kind of thing, especially when you're looking for the dopamine hit, right? And I will tell you a story. So I'm writing a new book all about unanticipated consequences of actions. And one of the unanticipated consequences of creating the vape pen, right? So wind time back, the vape pen was invented by a group of students at Stanford who actually built it as part of their final project for a class. Probably didn't know that. And they thought, what we'll do is we'll build and the goal was to reduce the number of people smoking, right? But the optimization algorithm for them was, we need people to come back and buy new vape pens and new cartridges and all that stuff. So if we bump up the nicotine level just a little bit, I mean, this is literally getting people addicted, literally getting them addicted. And so that had the unfortunate side effect of increasing total overall nicotine addiction counts, which is not probably what they intended. So what do you optimize turns out to be really important. So we've talked about things about user recommendations, changing user behavior. Think, for example, about the very first slide I showed you about the auto-completion. One thing that's fascinating about that, and the question we asked, was, does the use of auto-completions change the kind of queries that people make? And with simple autocompletes like we saw, it actually didn't, which was a surprise to us, which was great. But other things, actually, uses of, say, movies and books and so on, the recommendations have a huge influence on user behavior. So what people do, unsurprisingly, affects what other people do and what they like and don't like, as you expect interactions in real life. So this is called the contagion effect. So some contagion effects are very predictable, but some are random, which was a surprise to me. So for example, there was this really interesting study done a few years ago where they set up an artificial market. And the beauty of this study was they set up this artificial market for music, and they say, you know, they're going to study what people like and they don't like and so on. And the surprising result from this was that they would introduce songs in different sequences in different groups, so you have different populations. So we're going to have group A over here, and group B over here, and group C over there. Okay? So group A, we're going to show you, we're going to recommend song 1, 2, 3. Over here, it's 2, 3, 1. Over here, it's 3, 2, 1. Okay? And then watch what happens with recommendations and evaluations and so on. And what they found is profound. They found that the order of introduction of the songs can have a profound effect on whether or not that song becomes very super popular. It goes platinum, basically. And what this tells us is that the recommendation algorithms, when a new item is introduced into the set, has a big influence on whether or not that goes popular. It's a contagion effect. So over here, A group gets 1, 2, 3, and you love 1. Over here, it's 2, 3, 1, you guys love 2. 3, 2, 1, you love 3, right? So each group now has this sort of weird introduction sequencing event, which is why people care so much that they get on the top of the recommendation list. So in Google terms, this is called search engine optimization. So if you're a new company, you've got a company that's selling widgets. So her company's over here selling widgets. But when I look for widgets on Google and you're on page 3, go away. So a whole industry exists to help your website rise in the numbers. Search engine optimization. Some of them are charlatans, but some of them actually do work. But there's a whole pile of money going into just that. And of course, Google at the same time is trying to make that go away, because they hate that stuff. They want natural, objective rankings. It's really hard. Anyway, this kind of thing happens. So this study is in an artificial market. This study did the same thing, except in naturalistic markets, found the same result. Awesome. So this artificial market had an insight which they then validated in real markets. So introduction and recommendations really do change user behavior profoundly. So when you think about recommendation systems, they're always embedded in a social network, right? Here, for example, is a social network where you've got these different people, all these different nodes, and they have some sort of set of social relations shown by the arcs, okay? In addition, that's the social network. So V0 knows V2, and V2 knows V3, and so on. In the activity network, this is what people are actually doing. So the first one is knowledge, the second one is behavior. And so behavior may or may not follow knowledge exactly. In this case, it doesn't. And so what happens is that activity and contagion follow sort of the cross product of both of those. In order to be influenced here by V3, there has to be an action, and knowledge is not enough. But it certainly helps. So if you basically ignore all, so V3 is not connected to V1 anyway, but it's possible, low probability that they will do something that will affect V1. So if you build this model of action and knowledge, you can have high quality prediction about the influence of different introductions, right? So recommendations are kind of like predictions. A prediction, I'm going to predict, my recommendation engine is going to predict that you're going to like this song. You'll really like this song. You really like this person. You will like this movie. Okay? But when you make recommendations like that, it's hard because, you know, Milton Friedman said stocks have reached what looks like a permanently high plateau just before the Great Depression. Television won't last because people get tired of staring at this box every night. And that's kind of true, except now we look at smaller boxes. Decca Records hated the Beatles in 1962. We don't like their sound. Children are not interested in witches and wizards anymore in 1996. And then, of course, I love this one by Thomas Watson, chairman of IBM in 1943, said, world market for about 5 computers. And multiple people repeated that and made their own. Ken Olson from Digital Equipment Corporation said, oh yeah, there's world market for 10 computers. Both these guys, who deeply embedded in technology, did not understand where the market was going. And I've made similar mistakes like this myself, where even though I know about Moore's Law, I know about network effects and all of these things, and I've talked about making predictions about technology for years, I made some profoundly dumb predictions, kind of on the order of this. So it's really hard. So this is all by way of saying, here's another paper on the same topic, what's called moral contagion. So where people are spreading ideas about ethics and moral standing and so on. And it follows the same model we just saw. Connections, social network, social graph, activity. And it's exactly the same kind of behavior. And so you end up with, this is the network graph of moral contagion in the US by political ideology. So these are, what the links are, is connections patterns between people of either the blue color or the red color, right? And so you get these very tightly packed organizations with very few blue dots in red and no red dots in blue. So it's a little asymmetric, but you see the pattern and you see the problem. You end up with 2 universes that are fundamentally disconnected. So I'll tell you what, let's break right here for 5 minutes and come back at 9 o'clock and we'll pick it up. So the question for us now as HCIAI researchers and engineers and potentially product managers and so on, how do we build a better one? How do we build one that actually has all the good effects without any of the bad effects? So as you might expect, right, people are trying to use neural nets to do better recommendation systems. And in some ways, they are actually better at recommending things. They get higher click-through rates and so on. It didn't actually solve the problem, the ethical problem, the dopamine problem. So there are these things out there which are, for example, extracting what are called latent factors. And those are proving to be quite effective. But again, the way you optimize a system like this is you determine what the measured dependent variable is, and that's what you're trying to optimize for. So what would be your better recommendation systems? There's something we could do with large language models that would help? I'm asking you, my elite group of advisors here. Is there some way we could use currently existing AI technology to help with recommendations? And importantly, is there, the other thing I want you to think about, how could interactions with recommendations be better? Because right now you get a list, right? Is there any better way to deal with that? And now you charm me with your ideas. What do you got?
I mean, in the case for perplexity, for example,
Mm-hmm.
it's also, I think they want to pivot to a model where the recommendation of the source, which is like cited
Yep.
in perplexity,
Yep.
is also recommended basically like an SEO in Google. So the company which pays the most, that's the citation. So
Okay, so that's a financial transaction, basically.
I guess.
Yeah. Okay. You think that would be better? It's going to reward rich providers, right?
I don't think it's necessarily better for the
Yeah.
output, but
Okay.
I don't see another way they could do it to
Got it.
monetize.
Okay. So monetization considered important. Any other approaches? Ideas? So let me tell you a story. In 1999, I was just a generic AI researcher, and I was using the latest, greatest search engine of the time, which was probably Yahoo, or maybe Hotbot, but there was a bunch of them around, and they were all kind of okay. And then Google came on, and Google came online, and it was clearly, instantly, obviously much better. It wasn't even close. Basically, there was a huge migration away from all the other things to Google, which then took down the server, but that's another story. And it was clear that PageRank, the algorithm, was measuring the quality of each page and making recommendations based on that. And that worked really well for probably 10 years, and then things got complicated after that. And so the Google algorithm right now is no longer just PageRank. PageRank is a tiny fraction of it. But it was one of those moments when you see the improvement, obvious improvement of an algorithm, right? It was just amazing. It spread very, very quickly. So in this case, the interaction model with Google, as you know, is pretty simple, very straightforward. You could show somebody that page and they got it instantly, no training time. So what would the perfect recommendation system do? So if you are looking for a final project, and again, this is foreshadowing. This is maybe something, here are 3 different repos you can go look at, or notebook, Jupyter Notebooks or something you can try out. There's a bunch of things. These happen to be about wine recommendation systems. You could modify the data set to be not wine, but friends or movies or, whatever. Clubs in Zurich, right? How would you do that? So there are a bunch of these out there. If you're interested in that, go check it out. And one of the things that I find super interesting is, as I mentioned, not only user behavior changes with time, but user expectations change, right? So one of the things that's very, very clear is that people are expecting different kinds of things. And as new technology comes and goes, we see that expectation shift over time. Right now, people are looking for more tailored experiences. So, for example, in the past 2 years, comparable searches without the words about me or near me have grown by 150%. That means queries with near me have gone down. Why? Because Google now assumes that that's what you mean. So if you're looking for example, you do a query right now for pizza, it will show you pizzas in Zurich, not in Mountain View, even though all the original training data was from Mountain View, California, right? But now geolocation is big, built in. So that's one thing. Another thing is that mobile searches, X for me, have grown by 60% for the past couple of years. In this case, queries like which running shoes are best for me, what dog is right for me. Now, that's a loaded question, right? Which haircut is best for me, which credit card is best for me, all asking for customization. And so you can sort of predict what happens here. So the YouTube recommendations are a topic that's been widely studied. And to your point, the dopamine reaction and the variable that's being optimized is watch time. So the more clicks, the more watch time you get, the better the algorithm will reinforce that recommendation. And so you get people posting things like this. They discovered something. They had a serendipitous moment. Awesome, right? This probably happened to you. You get a recommendation you never would have heard of otherwise. Works fantastic. But by the same token, one of those recommendations takes you down a rabbit hole, which can potentially have the dopamine hit. It can be positive or negative, right? And so there's been a lot of articles and a lot of concern inside of the YouTube group about how to avoid showing more and more violent imagery, more and more terrorist kind of stuff like that. Vegan Nazis, a thing I didn't even know about, right? And of course, it's possible to have both reactions to the recommendations. They're awesome, they encompass the world, it gives you a godlike overview, but at the same time, you get enough and it's low quality. So part of the problem there is you as a person, I don't mean you personally, but people in general, shift their attention and shift their focus, shift their interest. So what worked as a recommendation for me last year no longer works for me. I've seen all those videos. Now I need something new. So one of the possibilities here is how can you build a model of positive growth, new growth, serendipitous exposures. So there are a bunch of other factors in recommendation systems to think about. So this is all in the vein of how do we make a better recommender? So people want diversity in their results. And it's tricky, right? At Google, we spend a lot of time trying to figure out how to make the recommendations, the results list, diverse, but not so diverse as to drive people away. And getting that balance is why you're in an experimental group. Because we don't know where the balance should be. So we will experiment, say, oh, it's going to be 0.7, oh, 0.6, no, 6.5, right? And we keep iterating towards a better solution. So you need to support diversity in your results. There's also a thing called recommender persistence. So sometimes it's best just to re-show the previous recommendation. You want it to persist, okay? Or let users interact with it. So previous question was, how is there a better way to have a recommendation system UI? Maybe you allow people to drag things around and re-rate these things. I will tell you, people have tried that in the past, and it works for a while, and then people lose interest in it. So could we gamify it in some way? I don't know. Oh, I will tell you, actually, one thing about that is that Google Maps, for example, has done a really good job, I think, of giving people feedback when they add recommendations to the system. So I don't know if you know this, you can go to say, I went to this cafe down on the Altstadt, and I loved it. And you can actually add that review in Google Maps. And Google Maps has a great mechanism for giving you feedback about that. 10,000 people saw your review last month, right? And I'm just a kind of an amateur at this, and occasionally, 10,000 people literally saw my photo of this cafe, and I get that positive regard and positive feedback. So that's an example of the dopamine hit that's working for good for everybody. It encourages me to add more reviews. Okay. Privacy is the flip side of this. I don't want to. You may discover that I'm a vegan Nazi, right? And I only go to vegan restaurants. And it's not true, but you can imagine it being true. I'm from California, so that kind of thing happens. But you end up revealing information about yourself, both through your queries and through the reviews that you leave, even the ratings that you give. So how do we mask that, or what should be the policy for that? You have to realize that users have fall into different groups, right? So you are all in the student group, you are also in the living in Zurich group, and you're in multiple groups simultaneously, right? And so we know a few things about different properties and behaviors of different groups. For example, older users, and I mean more than 35, tend to be more interested in recommendations than younger users. But it varies by topic. Younger users love movie reviews, they love club reviews, and they don't care so much about book reviews. So the recommendation systems work differently. As I mentioned, serendipity is something everybody wants, except when they don't want it, right? So serendipity is this idea that when you get a set of recommendations, there's something in there that you didn't know about and is perfect. It's exactly what you want and you didn't even know it, right? So how can you build a recommendation system to maximize serendipity? Essentially what a serendipity system does is it makes a prediction about something you're going to be interested in. You will find this fascinating, and tries to amplify that signal. The problem is it's very hard. So lots of people I know have worked a long time on this problem, and nobody's figured it out yet. Obviously, you need to trust your recommender system. So there are a few people I trust. For example, I trust my mom's recommendation for making bread. She's the best. I do not trust her recommendations about movies. She has terrible taste in movies. So you have the same opinion about recommendation systems. So for example, Tinder may work really well for you, Bumble not so much, and you don't really care about what the reasons are. I trust one, I don't trust the other. Same problem. And one thing that's interesting to me is that the labels people put on objects matter a lot. So if, for example, you're looking at a product recommendation list, products that are tagged as being sponsored, right? You've seen the little sponsored links, right? That has a lower click-through rate than the same item that's labeled organic or bio, right? And that's even lower than ones that have absolutely no label whatsoever. So one of the upshots of this is labeling is bad, but there are other cases where labeling is good, because it helps you discriminate among items that look otherwise very, very similar. Okay, that's actually it for today. So I've given you this final question. And during the week ahead, just kind of pay attention to the number of times you hit recommendation systems, because they're absolutely everywhere. So just kind of keep track of that. And then tell me what your favorite recommendation system was for next week.